So start from number 7. I need to prove some numbers for you. Like this question is asking you to evaluate when the angle is pi over 6. Now, when angle is pi over 6 on the unit circle, you have pi over 6 here. Now, what's pi over 6? It is 30 degrees. Remember, I always talk about 90 degrees equals to pi over 2. So, if you divide by 3, 30 degrees will be pi over 2 divided by 3, which is pi over 6. You should memorize this. This is very, very special angles. So today we are going to talk about special triangles. Now remember last time we talked about 3, 4, 5 is so special. But the 3, 4, 5 we don't call it special triangles. Just the number is special. Okay? And it's all the whole number here so rare. We may say there's a rare triangles. That's fine. But when we talk about special triangles, we are not talking about those special this type of the triangles. Okay. Let me erase this one. So when we talk about the special triangles, basically we talk about two types. One type is 30 degree. Okay, 30 degree triangle. Let me draw the picture for you. If you have right triangle, special right triangle. Sorry, I need to say special right triangle. It's better this way. Special right triangle. So when you have one angle is 30 degree for the right triangle, then what's the angle for the other one? You have to understand all three angles plus together need to be 180 degree. So if you have 30 degree and 90 degree, 30 plus 90, 120. So this angle need to be 60 degree. So 30, 60, 90. This is one of the special triangle. That's number 1 we want to talk about, which is here. Pi over 3 is 60 degree. Okay, and then pi over 6 is 30 degree here. This one type. And the other type, we call it 45 degree, 45 degree, and 90 degree. 45 plus 45 plus 90, 180 degree. Now this type of triangle, we call it isosceles triangle. Why is isosceles triangle? Because when you have two angles the same, means these two sides equal. There's too much geometry concept. Right now I don't talk about too much detail right now, but in shortcut, if you have two base angle equal, then these two sides will be equal. Kind of like if you in the one triangle you have two opening, same opening, open the same size, then these two should be equal. Okay, on the right triangle, you can have that. So today, before I start the video, for number 7, I want to talk about how you calculate all the sides for these two special triangles. So if you have 60 degree, 30 degree, let me rewrite the 2 degree angle because pi over 6, pi over 3, you kind of not too familiar with that. So if I redraw and make it bigger, easier to. So if this is 60 degree, this is 30 degree. Okay. Now how I calculate the side? So pretend the r equals to 1. So let me build another triangle totally the same as like you fold your paper. To form the same triangle. So this one will be 30 degree, this one will be 60 degree, this one will be 90 degree for sure. Okay. Now in this case, what happened? Do you see that the whole thing is 60 degree? Yes. So when you have 60 degree, 60 degree, 60 degree for all three same, these all three angles, they are the same. Then we guarantee all three sides are equal. If this is 1, this is 1. This also is 1. And remember, we fold the paper. We fold our paper, right? We fold our paper to have a new triangle. So if this is 1, here should be 1/2, 1/2. In other words, if radius is 1, this is 1/2. Make sense? So if this is 1, this is 1/2. By the Pythagorean theorem, you can calculate x. X squared plus 1/2 squared is 1. So let me calculate here. X squared plus 1/2 squared equals 1 squared. So x squared will be 1 minus 1/4 equals 3/4. So square root of 3 over 4. So this x should be, so x squared equals to this number. So x will be square root of 3 over 2. So this is how you get those numbers. Square root of 3 over 2, 1/2, when your radius is 1. Now remember, when you have a 30 degree here, where is 1/2? Opposite to the 30 degree is 1/2. Okay? And this is 90 degree. Opposite to the 60 degree will be a bigger size. So it's square root of 3 over 2. And this is 1. Okay? And for this question, I don't have space to talk about second spatial triangle, but I'm going to talk about it pretty soon. So let me erase this triangle for now so I may have more space. Okay. So 30 degree is erased. That's fine. Let me rewrite. Okay. So in other words, let me draw this picture here. When you have 30 degree, this 30 degree will opposite to 1/2. And when you have, for example, if we have see this is 30 degree, okay? And this is 60 degree. The 60 degree will face to 3 square root of 3 over 2. And this is 1/2. This is 1. This is 1. Okay? Now you should memorize those spatial numbers. How you memorize? I always tell my students to memorize this way. If you multiply 2 multiply 2, multiply 2, you may have 1, 2, and root 3. 1, 2, 3. Very easy to memorize. And then when radius is 1, then you divide by 2 again, divide by 2 again, divide by 2 again. So you have your formula. So your formula depends on what's your radius. And it's easy to memorize the triangle by 1, 2, 3 root. Okay. Therefore, go back to number 7. If you have a special triangle 30 degree, because pi over 6 means 30 degree, you should memorize that. And the opposite to the 30 degree will be 1/2. Adjacent to the 30 degree will be square root of 3 over 2, and the pi over 6 is on the first quadrant, so everything is positive. And the y value is 1/2. X value is square root of 3 over 2. This time I didn't make a mistake, so good. And the tangent is y over x. So y over x. You times 2 to get rid of small denominator. So you have 1 over square root of 3. Now be careful, you always want to rationalize your answer. So rationalize your answer, you multiply square root of 3, then that's final answer. Okay. So this is number 7, and then we keep going to number 8. Number 8, the terminal side. How you find the terminal side? Because this is okay. This is an improper fraction. Improper fraction, you want to make it become a proper fraction. This 1 and 1 over 6 pi. So it means this pi plus pi over 6. Pi and plus pi over 6. So it ends up with the third quadrant. Third quadrant, you have x coordinate negative, y coordinate also negative. So the sine value will be the y coordinate, cosine value will be the x coordinate, and the r is 1. You don't need to divide by 1. So sine value, y value, okay, is 1. And the cosine value, x. And this y over x, you need to simplify. Now, cosecant, cosecant, not cosecant, sorry, will be the reciprocal. So you just do the inverse, okay? Reciprocal. Reciprocal. And the reciprocal of the cosine is the secant. And the reciprocal of the tangent is cotangent. Number 9. So when you want to answer those special triangle value, you need to learn how to graph first. And this graph is very special here. When angle is negative, we go negative direction. And the negative 3 pi over 2. Negative 3 pi over 2 is negative pi over 2, negative pi over 2, negative pi over 2, 3 times, right? So end up with here. Wow. This negative 3 pi over 2. So the x value is 0. And the y value is 1. Okay? Therefore, sine will be here. 1. That's the y value. And the cosine will be the x value. Now, what's the tangent? 1 divided by 0, undefined. And the reciprocal, you just make a reciprocal. That's not hard. But this question, I would like to talk about. Some students will say, teacher, I don't see any triangle here, right? Trigonometry, you're supposed to see triangle. Where is the triangle? So I would like to talk about when you have terminal side and the initial side. Terminal side. When these two sides merge together, you have angle 0. When you have angle 0, you don't have angle, you don't have triangle. And it ends up with 1, 0. Okay? So if this terminal side smash down to the ground, then you don't see any triangle. So your cosine is 1 and the sine value is 0. Now what happened? Okay, so right now I'm going to do something very special for you by using this graph, because I have another thing graph ready there. So how about if I open my terminal side, keep going on, open and open. What happened? We can see this. So when these two sides merge together, we have 1, 0. If I open a little big angle, you can see that you have the y value a little bigger, right? And if you keep going on, make your angle bigger, your y value will bigger. Yes, y value bigger. And if you make your angle bigger, your y value bigger. In this time, when y value bigger, the x value becomes smaller and smaller, right? So when y value bigger, the x value smaller. So when y value bigger and the bigger here, when y value become 1, what happened to the x value? X value becomes smaller and smaller and smaller and smaller till become 0. So it's kind of an action. When angle become bigger and bigger, and the y value is bigger and the x value is smaller. Okay, and then when you go to here, y value becomes smaller and smaller, and the x value become bigger and bigger. So when you are dealing with trigonometry, I would like you to learn how to draw the picture all the time. You want to visualize everything. Okay, when you can see the picture, then you can obviously double check what's wrong or what's right for your answer. Okay, so let's keep going to number 10. Okay. Now, number 10 and the number 11. If this is a spatial angle, then that's fine, right? We can just draw a picture and we can find the answer. So number 10 and the number 11 is okay. But pretty soon we are going to deal with the angle, not the spatial angle. And we have some formula deal with plus pi minus pi plus pi over 2 minus pi over 2. So many formulas. And in this case, how you find your answer? Do you have to memorize all the formulas? I don't know how other people to deal with those values or formulas. I don't memorize the formula. I draw a picture to find my formulas. So that's what the next thing I want to talk about. But so far, I'm not going to go over those formulas yet, because right now we are still dealing with the spatial triangle. If we are dealing with the spatial triangle, we can just draw a picture and find the answer. Okay, but pretty soon you need to prepare for, we have more and more formulas for the general angle, not the spatial triangle. Now, 7 pi. Now remember, when you go around one circle, if you go around the one circle, we go back to the original position. Same thing, if this terminal side go around one circle, you go back to the same location. That's how we call period. The sine function and the cosine function, the period is 2 pi. So whenever you have 2 pi, they have the same value. Therefore, you may just ignore 2 pi. So cosine 7 pi, 1 pi, and the plus 2 pi, 2 pi, 2 pi many times. So end up with still equals to cosine pi. And what's cosine pi? Cosine pi is talking about the x value is on the negative side, so it's -1. We can draw a picture like this way. Now 7 pi over 3, 7 pi is 2 and 1/3 pi. So 2 pi, you may just ignore 2 pi for the sine function, because whenever you have 2 pi for the trigonometric function, it's just go back to the original location, and you are going to build the same triangle. If you build the same triangle, then they're supposed to have same value. And remember, we have, if you have 1/3 pi, it means 60 degrees. If you have 60 degrees, opposite to the 60 degree will be square root of 3 over 2, which you should memorize that. Yes, if you use calculator, you may find the same answer. Don't worry about that. Okay. On the test, you are allowed to use calculator, but I suggest that's often used numbers, you should memorize it. And for those formulas, as long as you are able to draw the pictures, it is still very, very helpful. So I don't think anyone are able to memorize sometimes negative, sometimes positive, right? Sometimes change sign, sometimes don't change sign. Too complicated. If you had to memorize so many formula together, it's too hard to memorize. That's why I don't suggest you simply memorize. You should learn how to find the triangle like this. If you know where is the triangle, then you know where is the value. Okay, so that's the number 10, number 11, and let's see what's number 12. Okay, so number 12 is the situation what I was talking about. If you have a negative angle, how you relate to the positive angle? What happened? Why is sometimes positive? Oh, okay. This is equal. Okay. So sometimes you don't change the sign. They have the same sign. Sometimes they have opposite sign. Why is that? Why sometimes it's the same sign? Sometimes it's opposite sign. Why is that? Okay. So we want to talk about y. But before you memorize the formula, we try not to memorize the formula and use concept by drawing. So if you have sine t, we don't know where is the angle t, but you can use an example here. If you have, for example, if the angle is positive, you go up, right? You go up. Then, if you have negative angle, you go down. And the sine value is talking about the y value. Therefore, when you go up, you have positive. When you go down, you have negative. Therefore, the sine value for positive angle and the negative angle need to be opposite. So, if your negative t is positive, so means your negative t is here, okay? And your positive t will be there because negative t means negative, like a negative something, okay? So this is positive angle and this is negative angle. So that's the concept. The positive input and the negative input, their output will be opposite sign. We call this is odd function. Okay? Odd function. Odd function is f negative x equals to negative fx. Therefore, the reciprocal, same thing. You just make it upside down. That's a reciprocal. Now, when we talk about cosine, cosine value, no matter the angle is positive or negative, okay? The cosine value, when you have opposite angle, they share the same cosine. They share the same cosine value. So, I will say cosine t equals to cosine negative t. They share the same. But actually, this question didn't ask about this question. It's asking about how about pi minus t. So this one too easy, didn't work. It's not talking about this question. Sorry about that. This question is even harder. Where is pi over t? For example, if this is a t, then pi over t, how you draw pi over t? Pi minus t, okay? Where is the angle pi? Pi is 180 degree. And the minus t, you go back t. So it means the reference angle. The reference angle is t in this case. So your terminal side is here. And this is the triangle you have to build. So if your cosine t is, this is cosine t on the right hand side, and the pi minus t end up with your x value to become the other side. So it's opposite. So cosine pi over t will be on the opposite side. This is cosine pi over t. Okay. Pi minus t. I always say cos pi over t. Pi minus t. So when you have angle pi minus t, your cosine value will be the opposite from the cosine t. Okay? Then you have negative. If this positive, then you have negative. Now, how about pi plus t? So if you have pi, let me change color to green. If you angle pi and the plus t, so the reference angle also t, but it's on the different location, right? So pi plus t, you have angle here, you have triangle built here. And the cosine value also is the opposite to the original cosine value. Therefore, is negative 6/7. Okay, so right now I'm going to end here, and I am going to start a new video pretty soon. Thanks. Bye bye.